Now in this lecture, we are going to discuss about the engine management system and its components. So before going to start the engine management system, one can ask the question, that is why it is required to study the engine management. When need to study the engine management? Why we require? Because engine is the heart of the vehicle, and the performance of the engine decides the performance of the vehicle. So to ensure whether the engine is working properly or not, we need to have the engine management system on this, which contains the various electronic components that we are going to discuss today. So it is important for a designer to produce a system in which various subsystems can work in harmony, so the system as a whole can work effectively. So the effective working of engine, we can correlate directly to the effective working of any car. So here, to ensure the effective working of the car, we need to ensure the effective working of our engine. So when we are studying the engine management, it is important to understand two aspects, and that two aspects are function and performance. Because as such, engine, if we consider as a system, to that engine we are having so many different subsystems, and every subsystems is required for a specific function, and the performance of each and every subsystem, we can correlate it with the overall performance of the engine. So when we are studying the engine management system, we need to take into account what is the function of that particular individual subsystems and what is the performance of that individual system. So firstly, the function of each component within a system and how that system works must be known and understood. Take example of engine fuel supply system. So in engine fuel supply system, you will find so many different components. That may be your fuel injector, that may be your fuel filter, or idle speed control system. So likewise, every component of that particular subsystem need to be known and understood first. And then secondly, you need to understand the system's performance. It is necessary to know the operating range of that system. Suppose I want to know the engine fuel performance system. So I must know what is the operating range of that particular fuel supply system and what are its components. So you need to know what each component should be doing under varying condition and what signal it should be giving, and if not giving a correct signal, why this signal is not being delivered or why malfunction is there. So right from the function of individual component to overall function and what is the expected performance level, that need to be understood before going for in detail discussion of engine management system. So the engine management system, generally we are calling it as a EMS. That is the first letter of this engine management system, EMS. EMS of any car. Now every car is coming up, every automotive vehicle is now coming up with the EMS, and this engine management system is how we can define this engine management system. It is defined as it is a self-contained custom-built computer which controls the running of an engine by monitoring the engine speed, engine load, and the engine temperature, providing the ignition spark at the right time for prevailing conditions, and metering the fuel to engine in exact quantity required. That means we need to monitor the performance of the engine at varying engine speed, load, and varying engine operating condition, that is the engine temperature. So these are depending upon many important two discrete subsystems, that is fuel or injection system, and second is ignition system. Especially ignition system will not be there as far as compression ignition is, or diesel engine is considered. Now if we take this engine control system, this is a car. This car is having the engine. This engine is having the ECU. This ECU will have the different, that is engine will have the different sensors. These sensors and these actuators, at one side to this engine there will be so many different sensors, to another side of that engine there will be so many actuators. So and from and towards the engine, you are collecting the information through the sensors, and you are controlling not only the engine and in its subsystems, but other vehicle systems also you are going to control. So here, sensors which we are fitting on this engine, they detect the engine operating modes, whether it is starting, whether it is idling, whether it is cruising. So these particular sensors detect the engine operating conditions or modes. Now here ECU, after sensing the information, this information is given to the ECU. This ECU elaborates the signal values, and according to the control strategies and algorithms which have stored in that particular ECU, this defines the actions to be delivered to the actuator. And as it defines the actions, according to the actions received from the ECU in the actuator, they actuates the defined commands. So this is the overall look or overall schematic of your engine control system. Now, if you go for the hardware architecture of automotive engine ECU, so here you will find this is a particularly the common rail fuel injection system. This is the common rail, in which you will find one component that is from this particularly it is an engine fuel supply system. Now in this diagram it is shown this is the fuel tank. In that tank you will find the free filter. From that free filter, the filtered fuel is taken with the this particularly again another filter which is outside the tank, and this filter is fitted with the water separator and heater, which is optional one. So after filtering here, pre-filtering, and after filtering outside the fuel tank, the fuel is taken in this particularly fuel pump. So this is the gear pump. So through this suction throttle, the suction of this fuel takes place, and in this particularly gear pump, the fuel gets pressurized, and this very high pressurized fuel is supplied through this high pressure line, because if you see this red line indicates the high pressure line, whereas this yellow line indicates the low pressure line. So here from fuel tank to the gear pump, you are observing here the low pressure side. So in the gear pump, you are increasing the pressure of that fuel, and that pressurized fuel is you are supplying it to the common rail. In that common rail, there will be respective as per the number of cylinders, there will be the different injectors. So suppose this is one injector, it is shown. So 1, 2, 3, 4. Likewise here it is shown, it is a 4-cylinder. So you may have 4-cylinder, 6 cylinders, 8 cylinders. So after coming here, the high pressurized fuel, this fuel is given to the injector. And this injector now injecting the fuel inside the engine cylinder, that is a combustion chamber, where it gets, that is mixture gets burned. Now, to this pressure common rail pressure line, you are observing here another one, the return line. Again, from this gear pump, you are again getting the return line here. So this is the input line, this is the output, and from that again here, this is the return line. So this return line is nothing but the overflow of that particular fuel. The overflow coming from this particularly common rail system, as well as overflow from this high pressure pump, and that overflow of that particular fuel is again given to the back to the tank. Now to this we are giving, or you are providing various information. That information, it is required at what pressure you are injecting the fuel. So rail pressure sensor will act. So this is a rail pressure sensor which senses the actual pressure of this fuel, and it is given to this particularly control unit. Now to know the various operating conditions of this engine, the accelerator pedal sensor is there, engine speed sensor, that may be the crank position sensor, that may be the cam position sensor. So all these sensors will give the information to this control unit and other sensors. So by giving this information to this control unit, from the same control unit, you are giving the commands to the actuator as we seen earlier. That is according to the requirement, the various commands will be given to the various actuators, and according to the commands received from this control unit, the various actuators just like as a fuel injector solenoid will work. Now, what are the engine control components? So this is another one schematic which describe the engine control components. Here you will see what are the different other components which you are observing. So here this is the engine. So to this engine you are supplying the fuel. So this is the fuel pump. So from that fuel pump there is a fuel filter, fuel pressure control mechanism is there. From that fuel filter it is given to the fuel distributor. From that fuel distribution here it is given. So this is nothing but it is the fuel injection valve. So fuel is injected here. So this is the intake manifold. So this intake manifold here there is a throttle valve. So there is a throttle control actuator is there, and this throttle control actuator is again connected to this particularly engine control ECU. Now this is the fuel supply system. So through this particularly passage you are supplying the air. So fuel and air you are supplying to this engine through this particular air that is intake valve, and this is the second. So this is your exhaust valve. In between intake and exhaust valve, you are observing here the spark plug. So second number indicates here it is a spark plug. So when you are entering, that is air fuel mixture gets introduced here, then because of this piston movement up and down, TDC and BDC having the various strokes, the fuel gets burned here, and during the exhaust stroke, this exhaust valve gets opened, and through this open exhaust valve, through this particularly exhaust manifold, the exhaust gases gets thrown away in the atmosphere. So this is the silencer. Now before that silencer, here you are observing the lambda sensor. Now to this engine cylinder you are observing this is one of the sensor which we are calling it as a cooling fluid temperature sensor, and this is another sensor which you are observing here on this. Generally this is fitted, this particularly third knock sensor is fitted on the cylinder head, so that by observing or by sensing the engine vibrations one can identify whether there is a knocking or not. So there is a knocking detection. So you are supplying fuel from this line, air from this line, you are burning this mixture here, and you are exhausting the exhaust gases through this. So here if you see, when your air is passing through this, you need to know also the air temperature. So air temperature and pressure. So this fifth, this is called as a NTC pressure sensor. What is NTC? That is negative temperature coefficient pressure sensor, and this pressure is of not the fuel, the pressure is of your air. So at what pressure air is being introduced, at what pressure fuel is being introduced. So to activate this particularly spark, you will have the ignition coil array. So here additional one, active charcoal filter unit is also you are observing. So through this charcoal filter you are getting the, actually you are getting this particularly exhaust recirculation, exhaust gas recirculation. So if you observe this here, to this engine control unit you are supplying the information of your pedal position, you are supplying the information of your speed, what is the camshaft speed, what is the crankshaft speed, and after this particular you are trying to control the entire operation of your fuel and ignition system. Because in engine management system basically you are controlling the engine fuel supply system and you are controlling the ignition system. Now if you go to the engine management system, what this engine management, these are the two figures which indicates the difference between conventional engine control and engine electronic control, that is microcontroller based engine control. So in conventional engine control, you are controlling the supply of the fuel by pressing that particular accelerator, that is the throttle. So here you are pressing the throttle by the driver. Driver presses this particularly accelerator pedal, and as he presses the accelerator pedal, he opens or closes the actual throttle. And by operating this, he is going to control the air fuel mixture. But this is not going to happen in case of microcontroller based engine control. Here, in between the mechanical linkage, that is driver and accelerator pedal and accelerator, you are having the ECU, that is electronic control unit, and this electronic control unit is having the ability to adjust, because air is being passed and here you are injecting the diesel, so or the fuel. So fuel and air is being supplied here, and whatever the air passes through this, we are giving the that is controlling the air fuel mixture. So with the help of this ECU, you are actually adjusting the air, what is the quantity, how much quantity of the air being passed and how much quantity of the fuel which we are injecting through this particularly injector. Now to achieve this, you are utilizing the ECU. The physical appearance of this ECU is like this. Now this ECU, engine management ECU, what is the function? It provides the real-time regulation of both fuel injection and ignition timing, thus simultaneously guaranteeing maximum engine performance and minimum fuel consumption. So you need to increase the performance as well as you need to minimize the fuel consumption. That means you need to achieve the more and more fuel economy. Now, what are the customer benefits? Customer benefits because of this engine management ECU is you will get the improved exhaust gas after treatment systems. You will save the fuel, that is greater fuel saving you will get, and you will have the better engine protection. Your engine life will get increased. Now, if you go for your ECU hardware, in this hardware, you will see this is the ECU connector. These are the some of the different connectors. In this ECU, you will find the input and output interface. Below that, as it is a microcontroller or microprocessor, you are having the ROM, RAM, EEPROM, NVRAM, that is a read-only memory, then random access memory, electrically erasable and programmable memory, or non-volatile random access memory. All these are the memories wherein the real-time data gets sensed and it gets compared with the already pre-programmed data. So here you will have the software, just like you will have the software. Now from this particularly, you are getting the regulator power supply module, that is RPS. Here there will be the dog, that is clock dog will be there, that is the system clock, which will be called as oscillator. And here there will be the microprocessor or microcontroller, which we are calling it as a CPU, central processing unit, which is the heart of that ECU. Now, if you go for ECU system blocks, in that ECU you will find the microprocessor, microcontroller. Now, in that microcontroller, which executes the instructions as coded and generates output signals by processing the information using specified control algorithms. Now, what input and output interfaces we are having? In input, you are utilizing the sensors. These sensors register the operating conditions and the desired value. So if take example of if I am taking the using the sensor, that is the crankshaft sensor. So the crankshaft sensor senses the actual rotation of the crankshaft. So real-time data is being sensed by the sensor and it is given to the CPU, that is ECU. And output of that ECU is nothing but the actuator. This actuator converts the electrical output from ECU to mechanical parameters. That means if I want to change the fuel delivery or the fuel pressure, so the actuator will actuate the fuel injector solenoid valve, and that solenoid valve gets changed. changes the actual delivery. Now in memory, as we seen earlier, it is a boot memory, program memory, calibration memory, data memory. So this calibration memory mainly it is required for your calibration purpose. That is, whatever the real-time data you are receiving from the sensor, you need to compare it just like as a comparator. You need to compare it with the programmed information, and if you will find if that particular uh, whatever we are calling that is a comparison, if you are getting some differences, then according to that you need to give the commands to actuate the actuators so that it will get corrected accordingly. Now if you see the ECU structure here, in this ECU here you are getting the engine input signal from the engine, you are getting with the help of this particular uh, crankshaft sensor. So from that crankshaft signal, it is coming in the analog form, but this analog form will not be readable by this particular microprocessor. So we need to convert this analog into digital. So there is a analog digital AD converter, analog to digital converter is there. So this digital converter will be sensed by this ECU, that is microprocessor, microcontroller will read that particular digital form. Then there will be the event controller, that is TPU, which we are calling it as a time processing unit, which synchronizes the control command with the reciprocity action of IC engine. Now whatever the input that is information taken from that particular sensor through this ADC, through the microcontroller, it converts into now the digital one, that is analog one, because this is required to be supplied to the different actuators, and actuator doesn't know the language of your digital. So it required to convert digital into analog converter. So here you are getting the digital to analog converter. So analog output you are getting, and this analog output you are giving to the actuator just like as amplifier, relays, etc. And this particularly commands is given to these various actuators. So here you are comparing real-time data with this pre-programmed data. So already in the TPU, that is the time processing unit, you will have the data of crank and angle pulse relations. So according to this, you are getting the control over this actuator. The structure of this ECU. In previous one of the slide, you have seen the output, that is physical output appearance of this particular ECU. Now inside that ECU, you will find so many transistors, so many resistors, and other electronic components, diodes, triodes, etc. So this is the actually the inside structure of this ECU. Now what are the advantages of an ECU? ECU reduces the exhaust emission, it increases the fuel efficiency, it improves the drivability, smoother or quieter engine operation, it have the safety functions, it have the comfort functions, and it will have the interaction with the other systems, and very important, that is we can have the diagnostics. So there are two different types of the diagnostic: onboard diagnostic and offboard diagnostic. So onboard diagnostic OBD, now which is now the primary requirement of your Euro 6 engines. Euro 6 now after 1st April, now every manufacturer is supposed to manufacture the engine which complies with the Euro 6 norms. So in Euro 6 norms, it is mandatory to have the OBD, onboard diagnostic system. So with the help of this electronic control unit, we can have the diagnostic also. Now what EMS do, that is engine management system, as far as petrol engine is considered and diesel engine is considered. In diesel engine, this engine management system controls the fuel injection rate, it controls the emission, NOx, it regenerates the oxidation in catalytic converter, it controls the turbocharger, cooling system, throttle, likewise. Whereas in diesel, this engine management system controls the lambda. What is lambda? Lambda, we are knowing that it is the stoichiometric air-field ratio. If lambda is equal to 1, that means you are supplying the correct chemically correct ratio. If lambda is less than 1, that is 0.9, 0.95, then mixture is said to be rich. And if lambda is more than 1, that is 1.1, 1.2, then mixture is said to be weak mixture or lean mixture. So as said earlier, in petrol engine, we are having the onboard diagnostic, cooling system control, ignition system control, lubrication system control, that is other system controls, then fuel injection rate control, throttle control. So these are these different functions that engine management system does on petrol and diesel engines. Now, if you go for digital electronic engine components, engine control components, then you will see various linkages like this. This is the engine. To that engine, you are supplying the air fuel mixture. So fuel you are supplying from this, air you are supplying from this. So to know the air content, that is pressure, here you are having the map, that is manifold absolute pressure, then throttle position sensor. So with the help of that, you are controlling the amount of air to be supplied to this particularly fuel metering, so that we are getting the correct air fuel mixture to the engine. So this fuel supply system, you are getting the input from the various that is position sensors, then cycles, then crankshaft position sensors and all. And from this control, you are getting the control over this input and output. So there will be again connection to this EGR, exhaust gas recirculation control. So whatever the sensors senses, that data is given to this microcontroller, and from that microcontroller it controls the fuel. This particularly again microcontroller gives the information of this real-time information to this ignition system. So ignition system also get corrected according to the input data and required engine conditions. So you are controlling the air fuel mixture from this side, you are controlling the ignition from this side. So actually you are controlling the combustion inside the engine cylinder, and through that you are getting the power and the exhaust gas. Now another one closed loop system. In the exhaust gas, you are having the HEGO, that is heated exhaust gas oxygen sensor. Then differential pressure sensor is there. At what pressure the exhaust gases are going towards the three-way catalytic converter. So there will be the EGR control. So from that EGR hole and EGR control, you are again giving the information to this particularly microcontroller, and the some of the gas, exhaust gas, you are again recirculating it to the input. So this is the exhaust gas recirculation wall. So these are the different components which describe the digital electronic engine control system. Now, what are the control modes for the fuel injection system? So the engine control system is responsible for controlling fuel and ignition for all possible engine operating conditions. So what are the possible engine operating conditions? That is, what is the idling, what is the cruising, what is the acceleration, likewise. For a typical engine, there are 7 different engine operating modes. So what are that? First, it is the engine crank. Second, it is the engine warm up. Second, very important, engine warm up to get the that is operating conditions, normal operating engine conditions. Then third, it is the open loop control. Fourth, it is a closed loop control. Fifth, it is a hard acceleration, that is cruising. Sixth, it is a deceleration, and last one, it is the idling. Now, what are the control objectives of this controlling mode of the fuel injection system? It needs to increase the fuel efficiency, it limits the emission, and also improves the vehicle performance. Now, fuel economy improving, various fuel economy improving technologies we are observing in our latest automotive vehicles. In many vehicles, you will observe, that is, you might have heard about the cylinder deactivation, wherein by use of this, there is a potential efficiency improvement is 8%. In many engines, you are now observing the variable valve timing and lift, that is VVTI and EM. The potential improvement, efficiency improvement is 5%. Then you are observing electronic injection, which improves the efficiency 12%. Then you are having the IHG. We are not going to utilize separately starter motor, separately generator or alternator. Combining one integrated starter motor and generator, it increases the efficiency of 8%. And now engines are fitted with the turbocharging and supercharging, which increases the efficiency of 7.5. Now if you see only the control of airflow ratio, what are the module components? Now here you are observing the piston and cylinder arrangement. Here you are taking the intake air. This is the injector. This is the inlet valve. This is the exhaust valve. In between that we are having the spark plug. So through this intake valve you are getting, through this injector you are getting the injector, that is fuel. So fuel is you are taking here, air you are taking here. So to control this air fuel mixture, what are the different components you are utilizing? First you need to know how much that is what type of exhaust you are getting. So to get this in the exhaust, you are fitting here exhaust gas oxygen sensor before catalytic converter. So this exhaust gas oxygen sensor will observe the air fuel ratio, and this observation may be of your sensor delay or cycle delay, with respect to the sensor delay and cycle delay, and this information is given to the controller. This controller is now giving that is taking the information with the information which we are receiving through this injector. So here injector fuel quantity you are getting from this particularly fuel injector. So there is a base fuel injection pulse module is there. Now this feed forward loop you are giving here. Now there will be the fuel film compensator is there. So desired fuel air fuel ratio you are setting here. Air fuel ratio set from the torque control module. So whatever the base fuel injection pulse module, this information is given through this particularly injected fuel quantity. It gets compared here with the air fuel ratio observer taken from this particular exhaust, and the injected fuel is controlled with the help of this injected PWM, that is pulse width modular. Now this is the control of your fuel. Now control of your air, we need to know at what time the fuel should be injected as well as the ignition should occur. So to identify that, we are having here the crankshaft speed sensor to know at what position the piston is and at what speed the piston is. So with the help of that, it is given to this particularly again controller. So here through the intake air, you are having the intake pressure as well as the temperature sensor. So this again information is given to this, and with the help of this you are now having the mass airflow sensor. This mass airflow sensor, whatever sensor you are having, that mass air enters into the cylinder with respect to this particularly through this particularly intake manifold. So in this way you are controlling the amount of air to be inducted in the combustion chamber through this intake manifold, and amount of fuel which is to be injected through the injector. So likewise, you are trying to control the air-fuel ratio. Now, electronic throttle control module, if you see this is the mechanical approach what we see. That is, the driver presses the accelerator pedal and it is directly connected to the throttle valve. Now, in between the throttle valve and the particularly driver's accelerator pedal, here there is an engine management system. So here you are taking the information at what angle you are pressing, and corresponding to that angle you are making the software calculation, that is with respect to the angle opening, how various that particular fuel injection and ignition will set. Now in this particularly here again you are getting the oxygen sensor, here spark plug, injector. So here in this you are getting the airflow, air intake in the manifold, wherein you are getting this particularly TPS throttle position sensor, wherein you are getting this various idler that is idler motors and all. So with the help of this TPS sensor you are getting the electronic throttle body, ETB, which is fitted in the intake manifold of the SSI system. So the information from this is given to the engine management system, wherein there is a controller. In that controller, you are having the different drivers. That is, HP's driver is there, then injection driver is there, ignition driver is there, which controls the fuel to be injected and the time at which the spark should occur. So likewise, we can utilize the electronic throttle control module in this way. So the throttle valve position is operated by means of mechanical or electronic means. Now, what are the advantages of using electronic engine control? All aspects of engine operation monitored and communicated to the operator. And one of the first important advantage is you are getting the outstanding performance as far as improved engine response is considered, precise engine control, speed control is considered, optimized engine acceleration is considered, slow engine speed control system is considered, or increased reserve power is considered. Another one, you are getting the fuel efficiency, better control of fuel delivery, efficient use of turbocharger, reduced operating costs, reduced lower emissions, because you are trying to get the complete combustion, reduce the white smoke during the startup, because according to the starting, you are supplying the required mixture strength, minimum black smoke during the acceleration and constant operating speed. Another one, it is the diagnostic and troubleshooting capabilities. We already seen that with the help of this engine management system, we can have the diagnostics easier. So detects and log abnormal conditions through the onboard diagnostic and outboard diagnostic system, provides visual and audible warning notification. In OBD, you are observing on the instrument panel EMIL, that is malfunction illumination light. Another one important advantage is greater reliability. Primary and backup ECM is there. Electronic engine control module is there. Sensor, battery system likewise. Self protection system with overrides are there. Transmission alarm and monitoring. Whether your vehicle is in gear, that is in first gear, second gear likewise. Then in system, as far as system integration is considered, because of this engine management system, you are having the better transmission control, better obstacle monitoring displays, and you are having the multi-station control. So here we conclude the engine management system. So in this engine management system, we have seen what do you mean by this engine management system, wow, what are the different components of this engine management system as far as SI engine and CI engines are considered. With respect to the engine management system, what are the, how we can control the fuel supply system, how we can control the ignition system, what are the different mechanisms or control modules which we are using under this EMS, what are the advantages of the EMS. So this is all about the engine management system. So thank you.